Hello and welcome to this advanced session on FHIR Shorthand. I'm Miriam Baltus, I'm from FHIR and I will be your moderator today. With me is our speaker Chris Moesel from MITRE. So welcome Chris, and please take over the screen when you're ready.
Okay. Thank you. Hopefully you can see my screen and hear me. Excellent. All right, welcome to the Advanced FHIR Shorthand and Tools tutorial. We're so glad that you're here. A couple of things. My name is Chris Moesel. I am a Principal Software Systems Engineer at the MITRE Corporation. I also have here with me Mark Kramer, our Chief Engineer at the MITRE Health Innovation Center. If you're not familiar with MITRE, MITRE is a not-for-profit organization that runs federally funded research and development centers. And we've been doing a lot of work in the health space in the last decade or so. And if you recognize any of those applications or those standards that you see on the bottom right-hand side, MITRE was a part of actually creating those things. So that's enough about us. You are here actually to see FHIR Shorthand, and my slide is not, there we go. So this is all part of a Let's Build a FHIR specification, and it looks like we have reached the end of the road here for that track. In fact, if we were to use an aquatic metaphor, perhaps we are at the last port of call before your final destination in the wrap-up session coming up right after this. So thank you for joining us. If you missed some of the previous FHIR Shorthand talks that were on Tuesday, I'd encourage you to see them because they were pretty darn good, and I enjoyed them, and I think you might as well. So I want to provide a little bit of background before we go into this. And basically, FHIR Shorthand, hopefully you know what it is because this is an advanced tutorial. I'm going to make some assumptions about that. But if you don't, you do need to know that it's essentially a way that you can create content for implementation guides, and specifically profiles and extensions and things like that. It is one of several approaches, but what differentiates this one is it's really kind of a domain-specific language, text-based approach to profiling. And here you can see an example of what it looks like to create a profile using FHIR Shorthand. Now, that's about as much background as I'm going to give you on FHIR Shorthand today. I do want to point out, however, that you'll notice that at the bottom of many of these slides, there's a tiny little link for bit.ly. If you actually click on that link, it will bring you to Fish Online. It will load up that example content for you that we're looking at on the screen. So this is a way when you look at the slides later, you can very easily get to these examples, and you can even play with them. And we'll show you how that works later. But I did want to point that out now. So for this presentation, we're going to be focusing a lot on what's new in Fish Stew 2. I feel like a little bit like Dr. Seuss saying that. But basically, what's coming up in STU2 for FHIR Shorthand? Now, some of you might be concerned about our friend Mr. Fish here. I already have received some complaints about this slide, but I assure you he's just fine. It's like a hot tub for him. He's enjoying his time. Fish will survive this. So we're going to spend some time looking at some features, and then we're going to spend some time looking at some tools. So the first feature that I wanted to show you is soft indexing. Now, for those of you who have been around the FHIR Shorthand block for a while, you may already know about this one because we introduced this one shortly after STU1 came out. But the problem that we're trying to solve with soft indexing is how do you manage very large lists or arrays when you are creating instances in FHIR Shorthand? Now, in STU1, you actually had to number all the items in a list explicitly. So you had to say item 0, item 1, item 2, item 3. And the problem with this is that it was very tedious, and it was also error prone. It's very easy to miss a number by mistake or to repeat a number by mistake. Another problem was that if you decided you wanted to insert something or remove something, there were some consequences there. If I wanted to add something in slot number 3 of a list, it means that everything after slot number 3, I now have to renumber. So it's very annoying. And then another problem with this approach with using explicit numbers is that although we see some patterns of code here that look very similar, we can't actually reuse any of them because that index number is built in. So it would only be helpful if we were trying to reuse it in some other profile or some other instance that had exactly the same numbering scheme. So what we wanted to do was create a way that you could actually refer to items in a list without having to use explicit numbers. And the idea is that we introduced symbols that indicate when you should increment to the next item in the list and when you should stay on the same item as you were previously using. When you use a plus sign instead of a number, that's basically saying go to the next item in the array. And when you use an equal sign, that's basically saying I want to continue addressing the same item as I was previously. Using this approach, we can actually create very large lists without having to worry about counting, because counting can be hard. I mean, I have a degree and counting is hard sometimes, right? We can easily add, remove, and move items around, because when we want to insert something in the middle of an existing list, it just works because everything is relative to each other. And those numbers don't get assigned until the actual instance gets processed. And then lastly, this actually allows us to use some of this code in rule sets so that we can reuse it and we don't need to worry about explicit numbers being hard-coded into the rule set. Which brings us to our next topic. So for those of you who are familiar with FHIR Shorthand rule sets in STU1, a rule set was a way that you could create a block of code that could then be inserted in other arbitrary places in your IG. So if you always wanted to insert the same thing in multiple places, you could use a rule set to define it once and then just insert it by name. Now in STU1, this was fairly limited because that code that was in that rule set was static. You couldn't change anything about it. But what we found was that there were a lot of cases where the context actually just required small changes to a pattern in a rule set. There were patterns, but they just had different, just slight variations. And so we introduced this notion of parameterized rule sets, which basically means you can define a rule set, but then also define substitutable parameters. So parameters that when you insert the rule set, they'll be substituted with particular values. So the easiest way to talk through this is through an example. So on the left-hand side of the screen, you see a rule set called context. This might be a rule set for adding context information to an extension. And it takes one argument. So we've defined it with a little parentheses after the name, and in the parentheses, we wrote the word path. And that means we are accepting a path as an argument to this rule set. And then within the content of that rule set, where we see the word path, that same word, with squiggly brackets around it, that's where the substitution will occur when we actually insert the rule set. So going down to the next part of the example, we have an extension called organization preferred contact. And we're just going to call insert context, and then we pass in organization.contact. And what happens is it invokes that rule set. It does the find and replace for path, basically, and inserts organization.contact. And you can see at the bottom of the slide the result of that. We now have a full organization preferred contact with that value inserted in. So that's basically how parameterized rule sets work. So I'd like to take you through another larger example using these two notions of soft indexing and parameterized rule sets together. So REST, so this is a capability statement example. And you can see that it's pretty complex. It's loosely based on something that we found in FHIR Saner. But really what it's just saying is it's saying that a server or a client should support measure, report, and a couple of profiles, and it needs to support the create and update interactions on those. And then the same thing for measure. But there's a lot of text to say that, a lot of complication, a lot of numbers. So the first thing we might want to do with this is replace all of the hard indexes with soft indexes. And we can see here that I've done that. I actually like to start an array with the number 0 explicitly, just as a bigger signal that this is the start of an array, but I could have used a plus there if I wanted to. But this is that same example using soft indices. You can also see that there's several layers of paths here. And when we go down the path to a subpath, we can also use soft indexes. And those soft indices are managed separately from the ones in the parent part of the path. So, all these resource indices are one sort of sequence of indices. And then within a given resource, we can see that the extension indices are a different sequence, the supported profile are a different sequence, etc. I've also replaced the extension URLs with an alias just to clean things up a bit more. So that's good, but we still could use some improvement because it's still hard to look at this and see what's going on. So now let's apply the parameterized rule sets. In the previous slide, we saw some patterns, right? We saw this pattern here for resources. We saw this pattern here for supported profiles, and we saw this pattern for interactions. So when we go to create our rule sets, we're going to create rule sets around those patterns. A rule set for resources, for profiles, and interactions. Within the resource rule set, for example, we are going to accept a resource name, and we're going to accept an expectation. That's your shall, may, etc. And we'll replace them in the proper parts of those shorthand rules. And by doing this for resource, profile, and interaction, when we actually get to defining the capability statement, now we just need to invoke these patterns as rule sets with the variable data. So support resource for measure report with a shall expectation, support this profile with a shall, and it shall create and update. That's a lot more straightforward. And when we look at it as a whole, we can see on the left-hand side our original approach, the middle with the indices, and the right-hand side actually has the use of those rule sets. And we can see that's a lot more compact. It's more consistent because we know we're repeating the same code over and over again. It's a lot easier to read. The intent just pops right out. It's easier to write, and we make fewer mistakes. So we're pretty excited about soft indices and rule sets. Now, I also want to tell you about logical models and resources, because this is something that we just introduced this week into Sushi. We have Sushi 2 Beta 1 that's out now, and it allows you to define logical models and resources. So logical models and resources are basically custom content structures. They are ways that you can define structure definitions, and you don't have to stick to the original elements that were defined in some core FHIR profile or some core FHIR resource, but you can actually introduce your own elements. Most of you are probably familiar with resources, but some of you may not be familiar with logical models. If you had a chance to see Jose's talk yesterday about implementation guides, he did a great job of describing logical models and why you would use them. But I'll just briefly state that logical models are a way that you can represent domain analysis models, as they call them in HL7, or DAMs, or you might be familiar with logical models from UML, but it's a communication mechanism. It's a way that we can talk about ideas and concepts and how we represent things between a technical team and subject matter experts and clinicians. It's a way to be able to understand a problem. And for that reason, it's something that's really recommended for use by IG authors, because in an IG, you can use logical models to kind of lay out the domain without having to worry yet about how that maps to these pre-existing FHIR resources through profiles. Logical models are fully FHIR conformant. It's a part of the spec. It's encouraged for use, and it is supported by the IG publisher. Now, resources are something that are similar to logical models, but they have a completely different purpose. Rather than communication between humans, resources are really about electronic data exchange, communication between machines. Another difference from resources and logical models is that for FHIR, resources are only conformant if they are actually published by HL7 for FHIR core. Using resources for proprietary uses or creating your own custom resources is usually discouraged. Now, there may be some use cases where it makes sense. If you are trying to model something outside of a domain that FHIR would ever even touch, or if you're using it strictly internally within your own business unit for proprietary data, then that might be okay. But by and large, resource development is intended for HL7 and HL7 work groups. And so what we hope by introducing it with FHIR Shorthand is that maybe HL7 work groups will begin thinking about creating and managing resources using FHIR Shorthand. So again, resources are only FHIR conformant if they're published by HL7. They're not supported by the IG publisher because you should not be putting resources into an implementation guide. So when you're developing logical models and resources in FHIR Shorthand, there's a few things to keep in mind. There is a new rule called the add element rule, and we'll discuss that over the next few slides. But resources and logical models also use some rules that are very familiar to you. They use binding rules, cardinality rules, flag rules, insert rules, obeys, and type. But there are a couple rules that you can't use. You can't use assignment and you can't use contains rules. And that's because the FHIR specification actually says that logical models and resources cannot have fixed values and they cannot use slicing. So there's no need for those rules. Also, it's good to be aware that logical models and resources are also not supposed to constrain elements that they inherited from their parent. So let's look at an example. This is an HIV record example of a logical model. It comes from the Open HIE HIV implementation guide. And this is how you can actually represent it in FHIR Shorthand. This is real FHIR Shorthand. It compiles into a logical model that when you push it through the IG publisher looks something like what you see on the bottom right-hand side. And you'll notice that those look very similar. The way that the shorthand looks mirrors the way that it looks when you look at it in a real implementation guide in the human readable differential view. That's intentional, and hopefully it's helpful. But there are a few things that actually make this view possible and make this type of writing logical models possible. And that's what we'll go over in the next few slides. So the first is the add element rule. The add element rule takes a few components. It takes a path. It takes a min and max cardinality, an optional set of flags. You have to declare what is the data type of the new element that you're adding, a short description and a long definition. But when you do this, it's essentially allowing you to create a first-class element within your logical model. No extension or anything like that. It's just like a regular element, a regular property that you can access. Now, the first example that I show here shows the minimum requirements for an add element rule. But then we also have something below it that's a little bit more complicated. It introduces flags. It has a choice. It's using a multi-line string for the long definition. So that's a bit more interesting. And then the last example is actually showing a backbone where you can create an internal structure within the logical model without having to define some separate type. So we're defining a service animal, having a name, a breed, and a start date. And that definition exists only within that logical model, similar to observation component in the FHIR resources, where it exists only in the context of a component. So again, this looks pretty familiar if you look at the format of the add element rule. There is one difference that you may have caught on, is in the differential table, the flags come first and then the cardinality. And here the cardinality comes first and the flags. The reason that we did that is actually to be more consistent with FHIR Shorthand STU1's cardinality rule, which does the cardinality and then the flags. And we felt it was important to be consistent with that rule. Of course, if you feel differently, this will be going to ballot in September, and we'd love to hear your feedback, or you can tell us before that. Another component of logical models that we were seeing in that first slide was a new way of addressing paths. Now, in STU1, every time you introduce a rule, you have to do a full path. So if you want to talk about something that actually has an element that's nested 3 levels deep, you have to go through that whole hierarchy. So in this example, towards the middle of the example, we see ARV treatment.course of treatment.treatment start date, right? And that's very explicit, and it's great because when you look at that rule, you can tell exactly what you're looking at. But it is also very wordy. There's lots of typing, and you end up with this wall of text or a sea of text, if you will. And some people really didn't like that, and they wanted to find another way. And so we thought about it, and we tossed around a lot of ideas, and we came up with indent rules, using indentation to denote path structure. And the idea here is that whenever you indent a rule by 2 spaces, you're saying that you want that rule's path to take on the context of the previous less indented rule's path. So for example, in this example, we see test results here. And then on the next line, we've indented 2 spaces and we have just results. So now this line should actually be interpreted as test results dot results. And similarly, test date. If you look up at the previous less indented rule, it's test results dot test date and dot sampling date, etc. And we can even go 3 levels deep like this. For those of you who are familiar with YAML, this may look very familiar to you. For those of you who use Markdown lists, it kind of looks like that as well. Some people really like this a lot, and it does actually create a nice visual representation of the structure. But some people really do not like it when white space is significant. They don't like the idea that these spaces are significant. So the good news is that it's up to you how you want to do this. If you don't mind this and you actually like this, do it. If you don't like this at all and you prefer the explicit paths without special meaning for white space, then just use the explicit paths, and that's fine too. So this is actually something that you can use in logical models and resources, but also in some of those things that FHIR Shorthand already supported, like profiles, extensions, mappings, instances, and then it also can be used in code systems. And that's what we're going to talk about next. Oh, not quite yet. Actually, we're going to take a quick look at a resource example as well. The main takeaway here is this looks just like the logical example, except it uses the resource keyword instead of logical. And I'll also point out that I chose to wrap my short and my long definition onto separate lines to make it a little bit more visually appealing. And I've also indented these. And I do want to call out that this indentation actually does not matter. This is insignificant. The only indentation that matters is when it comes directly before a rule marker, directly before this star. There, indentation matters. It will affect path structure. Indentation anywhere else, go for it. All right, so that brings us to another new feature in STU2, which is an advanced code system syntax. But first, let's talk about what we already had in STU1. In STU1, you could define code systems, but they had to be flat. So you could not define a code system using the code system syntax that had hierarchical codes or nested codes or codes with an ISA or parent-child relationship. You also couldn't define specific properties or designations on concepts within your code system. So if you needed to do either one of those things, you had to fall back on using the instance syntax. And I have an example of that on the right-hand side with the CDC race and ethnicity code system. This is how you would have to represent that in STU1. And you can see it's possible and it works, but it's kind of tedious, it's kind of repetitive, and it's definitely kind of ugly. And so we do like our friends who are terminologists and who do these sorts of things. And so we wanted to make them happy. And so for STU2, we introduced a few new features. By and large, the code systems that were in STU1 still work in STU2, but now you can do additional things. And I draw your attention to the bottom of the slide, the first blue section where we have a concept caret rule. This is how you can set the underlying property or designation in a concept, the way that you would see it if you look at the code system resource. There's a concept, and then under that, there's some properties. This is how you can get at those properties. You use the caret rule. Again, if you're familiar with FHIR Shorthand, then this is not a foreign concept to you. You already use caret rules to access the underlying properties of elements in a profile. Now you can use that same mechanism to access the underlying properties of concepts in a code system. So that's cool, but we also wanted to address the issue with hierarchical code systems because we've seen more than a few of those out there. And so we, again, wanted to borrow from what we already know with profiles and other things. And so we took this notion of a path and applied it to code systems. So now if you want to talk about a code that's several levels deep, you just talk about it in a pathy type of way where you first state what's the top level of that hierarchy, and then what's the next one down, and then if applicable, what's the next one down. So here we can see we've defined a code 3 levels deep for the Mexican ethnicity, right? So this is essentially how you can create hierarchical code systems now in STU2. But of course, since we introduced that nice indent syntax in other places, we wanted to support it here too. So this is yet again another way of representing that same information, but using the indent syntax. And here we can see that it's a little bit, again, more visually representative of the actual hierarchy of the code system. So that is also pretty neat. And again, if you like this, then please use it. If you don't like it, you can use the non-indented form as well. So we're pretty excited about these features, and this was also released just this past week. So now I want to jump into the tools portion of this talk and show you what's been going on in the tooling space. Now, this is not a fish that you would probably want to run into in your local swimming hole, but hopefully our tools are not quite as scary as that guy is. So we'll talk about Sushi, Go Fish, our VS Code extension, Fish Online, Fish Finder, and FSH School. Hopefully most of you are already familiar with Sushi, but Sushi is a command line client for converting FHIR Shorthand into FHIR JSON. I'm not going to talk a lot about Sushi version 1. We're going to jump right into Sushi version 2 beta 1. And the thing about that is it introduces support for all those things we've just spent the last 20 minutes talking about. So if you liked those things, then good news. You can start using them today with Sushi 2 beta 1. It also adds support for a few additional features, some of which aren't even listed here. But one I wanted to call out was what we call pre-processed fish output. And we'll show you that in the next slide. But I also do want to make you aware of some breaking changes that could affect you if you have existing projects. One is that in order to support the indent syntax, we made the space before the star meaningful. So that means that if you have an existing project where you just had like arbitrary spaces before a star, those spaces are no longer arbitrary. They are meaningful. And so when you run Sushi 2 against them, it's going to try to extract meaning from them and use that to imply a path. And you very well might end up with some errors there. Also, some syntax that had formerly been deprecated and was actually deprecated before STU1 became official is now no longer supported at all. I doubt that affects most people, but just want to call that out. And then lastly, early versions of Sushi supported other project formats, what we call the flat project format that could optionally have an IG data folder. We don't support that anymore with Sushi 2.0. We won't even try to process those projects. So if you are still on that old project format, you're going to have to upgrade to the newer format, which aligns very closely with what the IG publisher expects, where you have your FHIR Shorthand in an input/fish folder. So if you want to install the Sushi beta, you can. You do have to ask for it specifically by the beta version number, because we have it set up as a preview release, so that if you just install Sushi on its own, you'll get the most recent stable. But if you specifically ask for the beta, you'll get the beta version. So pre-processed fish output is a neat little feature that we added. You've probably noticed at this point that we've tried to add some nice features for authors that allow you to define things quickly and easily and succinctly. And it's great for authoring, but sometimes it's not as good for debugging, because when you're debugging, you really want to know exactly what you're dealing with and a closer representation of the real code that's being used to generate these structure definitions or what have you. And so if you run Sushi with the -p flag now, it's going to create a special folder called pre-processed. And if you look in that folder, what you'll find is all of your FHIR Shorthand definitions, but they're a little bit different because all the aliases have been resolved, all of the rule sets have been inserted, all of the paths have been expanded if you used indent paths, and all of the indices have been made explicit if you used socked indexing. So you get a much more detailed view of the FHIR shorthand. This can be especially helpful if you get an error from, say, the FHIR IG publisher that says your bundle.entry at index 54 has an error in it. If you look at your FHIR shorthand and you just have a bunch of pluses and equals because you're using soft indexing, you'd have to count like 54 pluses to figure out what's going on. But if you look at your pre-processed output where the indices are made explicit, it's a lot easier to find that section of the FHIR shorthand and then be able to ascertain what's really going on there. So that's a neat little feature. Hopefully you actually don't need to use it too often, but when you do need to use it, it's there for you and it can be very helpful. So the next thing I wanted to talk about is GoFish. GoFish is the inverse of Sushi. It allows you to take FHIR JSON and XML and convert it to FHIR shorthand. This is a work in progress, but it's getting actually pretty good. There might still be a few bugs here and there, but it's definitely worth checking out. We do allow you to export that FHIR shorthand into different file structures based on what you might like. You should be aware that currently it's kind of catching up to Sushi 2, so it supports all of what's in FISH STU1. It supports soft indexing, but it doesn't yet support some of those other more advanced features. If you try to use GoFish with logical models or hierarchical code systems or concept caret rules, it's going to produce the instance representations of those instead of the first-class logical model or code system things. So if you have a lot of those in your project, you might just want to wait a little bit for the next version of GoFish, which should support all of those things. So I did want to quickly show you an example here. So here I have the package that I downloaded from US Core, and I'm going to expand that package. These are all the definitions that were created by the IG publisher when it published US Core. And I'm going to run GoFish on this package. So as we run, we might encounter a few errors. You can see we've already encountered one here, which is up here. Basically, this package contained 2 versions of the implementation guide JSON file, and it wasn't sure which one to use, so it's just letting you know that it skipped one of them. It's only using one of them, and that is okay. Another error that we encountered here is that we saw a duplicate name, the US Core respiratory rate profile. And sure enough, if you look at the US Core IG really closely, you'll find that they had a little bit of a copy-paste error, it seems, and the BMI profile actually got the name US Core respiratory rate profile. So that's actually a real bug that's GoFish uncovered as it was processing. So it looks like it's almost done here. And when it's done, it gives us a nice summary of what happened. Some people get confused by this last box where it says things like cuttlefish, 24 displeased. What do you do with 24 displeased cuttlefish? Well, that's really our attempt at a joke. It's more or less meaningless, but it will change depending on how successful GoFish is. These cuttlefish are displeased because we did have 2 errors. So just wanted to point that out there. But let's go ahead and look at the results that were put into a GoFish directory for us. We can see it created a very simple configuration file. And then we have our input. And the strategy that I used for the file system was to separate things by their kind. And so we could look at our profiles. And here we can see that we have FHIR shorthand versions of all of these US Core profiles. So that's pretty neat. If I wanted to convert FHIR shorthand into, convert US Core into FHIR shorthand, this gives me a great head start on doing that. So if you think that's pretty cool, then you should definitely check out Mark's Let's Build from last Tuesday, where he went over that in detail. And spoiler alert, at the end, he actually creates an entire US Core implementation guide that's using FISH definitions. So it's pretty neat, and you should check it out. Next, I want to show you the VS Code extension. We were already kind of taking a peek at that when we were looking at the US Core code. First thing you can notice is there's some syntax highlighting. That just makes authoring a lot easier when those keywords pop out at you. But I wanted to show you a few other things that you might not be aware of. One is go-to definition. So if you're authoring and you have a reference to another FISH definition somewhere in your project, like in here, we have a parent for US Core Vital Signs Profile. I can right-click on that, and I can say go-to definition, and it's going to bring me to the definition in my FISH project. That's extremely helpful if you have a large FISH project. Another thing that you can get out of this is what's called peek functionality. I know how to do this on the Mac. I'm not entirely sure on Windows, but on the Mac, if I hold down my Command key and then hover over one of these words, like vital signs, it just gives me a little bit of a preview of how that is defined. So I don't have to actually go there, but I get the preview of it. And that can be pretty helpful as well. Another feature is a way to navigate to documentation. So for all of the major keywords of FHIR Shorthand, profile, extension, code system, value set, etc., you can right-click on them and say, open FHIR documentation. It will ask you if you really want to do that, and you say yes, and it brings you to the definition of how to define a profile in FHIR Shorthand. So that can be useful as well. What's also useful, I find, is that if you actually put your cursor on a FHIR resource, if you're developing a profile or an instance, right-click and say Open FHIR documentation, then it will bring you to the FHIR documentation for that resource, which can be very helpful as you're developing FHIR Shorthand. The last thing that I want to show you as one of the features here in VS Code plugin is what they call snippets. And what snippets are is I can just type a few letters here, pro for FISH profile, hit enter, and it starts to fill out a template for me that has all of the major keywords that I might want to use. And one of the things that's kind of cool is as I type, you can see that it's actually filling out multiple fields at the same time, because often the profile name, the ID, and the title are related. But when I hit enter, it's actually going to transform a couple of those values. So when I hit enter, you can see that the ID actually was made all lower with dashes, and the title, we inserted some spaces there. And that's just following best practice of how usually people might want to format those things, makes it a little quicker. So now I can just keep on keeping on and start typing my rules. So that's neat. That's supported for profiles and extensions and value sets and code systems, not yet for logical models or resources, but we'll get there. So if you like this extension, you can find it in the marketplace, or if you just open a file that has a .fsh extension on it, then VS Code should prompt you to install this plugin, and I find it very helpful. So the next thing we are going to look at is FISH Online. And it looks like I have a couple more minutes here. So we'll go right there. This is an online playground for trying out and experimenting with FHIR Shorthand. You can see on the left-hand side, we can enter FHIR Shorthand. And we have a button here, Convert to JSON, which allows us to then run Sushi behind the scenes. Well, except we don't have to have it installed. This is just a web app. And see the results. And I can navigate the results over here on the right-hand side, so I can see all of the different objects that were created by that FHIR Shorthand. So that's pretty neat. Down here, I have my console. So if I want to actually see the log of the processing, I can see that. We can also do the reverse. We can go from FHIR JSON into FISH. So for that, I'll just clear my editor here. And I have a US core definition right here that I'm going to copy. This is JSON. And we'll go back to our FISH Online. We'll paste that in, say convert to FISH. And there we go. We have our FHIR Shorthand equivalent. So that's a great way of just seeing, like, how would I do this thing in FHIR Shorthand? Well, this is a quick way that you can do it. Also note, 3,823 lines of JSON is equivalent to about 40 lines of FHIR Shorthand. So there's a reason we call it shorthand. Now, if you thought this was really cool and you wanted to share it with somebody, you could click on this permalink that says Share FISH, and it's going to give me a URL that I can copy. I can send that to somebody, and when they visit it, it automatically loads up that FHIR shorthand for them so they can see it. This is really helpful, actually, by the way, when you're reporting bugs or questions or errors. If you can send us a FSH Online link that goes directly to code that reproduces that error or shows what you're trying to do, extremely helpful. So one other thing I want to show you here is brand new this week, and it's FSH Examples. FSH Examples is a place where you can go to just see some information or some examples of FHIR shorthand. This is still a work in progress, and not all of the examples are filled out, but certainly if, for example, you really liked the capability rules that we introduced in this tutorial, they're actually an example here. And you can copy that, close it, bring it over here. I'll just get rid of this, paste it in, and you're on your way. So that is FSH School. And last, this will take about 1 minute. Actually, let's just stay where we were. We're going to go back to school. This is FSH School, and this is your online portal to FSH Online that I just showed you. A lot of documentation about Sushi and Go Fish and etc. But also the last thing is this button, Who's on Board, will bring you to FSH Finder. Now, FSH Finder on a nightly basis will visit several select GitHub organizations, and it will look for FHIR shorthand projects. It'll aggregate them and then list them here. So this is a great place to go if you want to see who is using FHIR shorthand, what aspects are they using? You know, do they have profiles or instances or extensions? And to be able to then actually click on them and go and find them in GitHub. So for example, FHIR Saner, we could click on this and it brings us right to the Saner repo where we could check out their FHIR shorthand for examples. So that's a pretty neat feature, and we have cataloged 111 different FHIR shorthand projects. So well done, all of you out there who are using FHIR shorthand. So I think that's about the conclusion. We already looked at FSH School. We have some resources and tools. Thank you for attending the track and specifically this tutorial. And I left 3 minutes for questions. Go. I think you might be muted.
Sorry. Yeah, so there are 4 questions in the Q&A. So one of them is, does the Go definition work across files, or must all profiles be all the profiles on the same file? So that was, I think, on the Visual Studio Code extension.
It works across files, so it will work within your whole project. So whatever files are in your workspace in VS Code, it should be able to find any FSH definition in any of those files.
Okay, thank you. Then we have a question asking about, is there a terminal command to update to the latest Sushi version? I think you had that in your slide, so that might already have been answered with the npm.
Yeah, so going back to here, this is the command to install. It's also the command to update. So if you already have Sushi, you still run the same command and it'll do an update instead of an install. Okay, thanks. Is the hierarchy function in code systems to be used for post-coordinated SNOMED CT concepts? So post-coordinated.
I can jump in.
Yes,
I
sure,
can jump
please.
in. So, of course, SNOMED has its own hierarchy, so it's already defined. When we define code systems, we're defining local codes of our own. So it's actually very rare that relatively rare that you want to create a code system that has new codes. These are local codes and they won't be understood in the world of interoperability. So with respect to SNOMED, all you need to do is cite the number, the code number, in order to use it, and the relationships to other codes is already built into SNOMED. Over.
Right, thank you, Mark.
Yeah, well, then the last question, we still have just 1 minute. Where do we send our examples that you can feature in FSH examples?
I love that question. Did somebody plant that question? That feels like
no,
a
this
plant.
was from Hassan, so I do think
Okay.
that's one of our attendees there, not me.
Okay, great. So the easiest thing you can do is ask us on Zulip. If you don't remember this, we're glad to answer any questions on Zulip. But I think we have a github.com. There's an organization called FSH School. And in that organization, we have Fish Online examples. This is the repo where all of those examples are actually stored. And we've provided some documentation on how you can do example submissions here. So essentially, if you're familiar with GitHub, the best way to do it is through a pull request. If you're not familiar with GitHub and you don't want to try to figure out GitHub, then by all means, you can reach out to us over Zulip and just send us the examples and we'll do that for you. We do have a little bit of a vetting process. We want to make sure that the examples are good, that they're not duplicative of other examples we already have, but we'd love to have contributions.
Okay, well, that's the end of this session, I think, for time. So thank you so much, Chris, and also Mark for jumping in on that other question there. Thank all the attendees for attending this session. I think it was really interesting. So thank you, Chris, and I was happy that I could be your moderator here. So see you at the closing session.
Thank you.